Welcome back to chapter 11. We're going to continue on in section 11.3. Normal distributions today. Today's target is I can find probabilities using the normal curve and normal distributions. So we'll have that down. That is our goal for today. Okay. In chapter 10, we did probability distributions, section 10.6. 11.3 shows us another probability distribution. Normal distributions are modeled by the bell-shaped curve. A bell-shaped curve, if you take this graph, you kind of just connect the corners here. You kind of get this curve. It really, connect the corners on that side of it. It kind of looks like a parabola, which is a bell-shaped curve. So there, the bell-shaped curve is really like a parabola-shaped graph, an upside-down parabola. There's lots of data values that if you line up all the data values and stack them up in a graph or some sort of chart of this nature, they make a bell-shaped curve. So it's just that's the type of data we're going to be looking at in this section. Okay, what are the areas under the curve? Basically, a bell-shaped curve, if you take a data set and make it fit under a normal curve, there's some facts about this. And if you look at it, it's all in regards to the average and standard deviation. Now, we call this mu, this weird mu that looks kind of like an M right here. That's called mu. And really, it's just the average, X bar. We're going to use X bar more often, but in this graph, it uses that mu, which is called average. It's a Greek letter. So the average is right in the middle, whether it's here, or if you look, you can probably see over here on these graphs, they use X bar. But the average is going to be the tall spike in the middle. And everything is going to be based upon going above or below the average. You can normalize data can also be applied to standardized test scores or percentile ranks. But we'll talk more about that later. But if this is the average, we're going to call this, it's the average plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations as we go to the right, and we subtract the standard deviation as we go to the left. So normalized data takes the average and the standard deviation and breaks the data up into parts of this curve. And we can see as we get up to the right and to the left, the curve gets skinnier and skinnier. There's less data. So in normalized data, most of the data is in the middle. And in fact, you can see between 1 and 2 standard deviations from the average, above or below, we have 68.26% of the area. If we go a full 2 standard deviations above or below, then we can see that we have 95.44%. And if we go 3 standard deviations above or below, almost 100%, 99.74% of the data is in that interval. Okay, so that's what we're doing here with this normal curve. We're talking about the average and standard deviations above or below. In your book, the key concept, this is page 757 in your book, has kind of a similar graph. This is the one we're going to use more often. Some facts to know about areas under normal curve, and it might be kind of hard to read, so you might want to look at page 757. X bar is the standard mean of X bar and standard deviation has the following properties. The total area under the related normal curve is 1. So if you could add up everything and go out forever and ever, we can see over here it got really close, 3 standard deviations away, but the area is 1, or 100%. 68% we've said is between 1 standard deviation of the mean, within 2 standard deviations is 95, within 3 is 99.7. And we can see we're going to use this part over here the most often coming up. That's what we're going to use to see areas and to solve some problems as we go along. So you might want to have these copied down. If it's easier to turn to page 757 and copy this key concept down, pause the lecture and do it right now, or come back at later. Leave room for it in your notes. Okay, the normal distribution has a mean and standard deviation. Find the randomly selected variable, find the probabilities. So we're going to find the probability that our value x, we have it here, is between the average, right, the mean, and the average plus 1 standard deviation. That's what that means. We're not going to do that for everyone, but we're going to be in that interval. Well, that interval, here's X bar, here's X bar plus 1. So the probability that we're there is going to be in that bar. And we can see the probability that you're in that area is 34%. So the probability that we're between the average and one standard deviation above, that's 34%. Okay, the probability that we are between 2 standard deviations below and 2 standard deviations above, well, we can add up all of these. 2 standard deviations below, that's 1, 2, 3, 4. Well, that's 13.5 plus 34 plus 34 plus 34 plus 13.5, which is 95%. We can also get it from this interval right here, right? That's 2 standard deviations above and below. Let's go over here. The probability that you're less than x bar minus 3. Well, we don't really have anything, or we know that the whole thing adds up to 1, so we could do it 2 ways. We could add up all of these and subtract it from 1, or we can see less than x bar minus 3. That's this short little one right here, 0.15%. Very, very unlikely that anything is farther than 3 standard deviations away. Notice that because this is normal data and it's symmetrical, much like a parabola, that the areas or the percentages are mirror images of each other. If you look at x bar as our axis of symmetry, all values reflect equidistant away from that line. Okay. Okay, so here's another thing you're going to see in your assignment. They're going to give you some data, an average and a standard deviation. In fact, you might even have a little project that asks you to do something like this as well. Find some data with it and find an average and find the standard deviation. Okay, so then we're going to create our own kind of normal distribution curve. So find the probability that a randomly selected x value from the distribution is in the given interval between 200 and 240. Well, first of all, we kind of have to make our own chart, if you will, our own curve. And we know that if our average is 200, that 200 is going to be where x bar is, right here. Okay? Well, x bar plus a standard deviation, x bar plus 2 standard deviations, x bar plus 3. And then, of course, we go the other way. X bar minus the standard deviations. X bar minus 2. And x bar minus 3. So we can just do this real quick. If our standard deviation is 20, add 20, add 20, add 20, subtract 20, subtract 20, subtract 20. So now we can find any area we want. And if we want to know between 200 and 240, well, that's from the average to 2 standard deviations above. So the probability that we are between 200 and 240, that's the same as the probability of being between x bar and x bar plus 2 standard deviations. So if we look back at our chart, okay, and we get those numbers, you can look back at a previous slide, I can see between x bar and x bar plus 2 standard deviations, that's 34 and 13.5%. So 34 plus 13.5, not 1.5, 13.5, that's 47.5%. This one is 34, this one is 13.5. So we can do that with the data that they give us. Let's try another one. Let's try another one based on the same data. It says less than 160. Let's go back a slide. Less than 160. Oops. Less than 160. Well, less than 160, that's going to be less than 2 standard deviations away. It's going to be from here on down. So less than 260, well, less than 260, or excuse me, 160, is going to be the two tail sections here. Well, that's going to be 2.35 and 0.15. So 2.35 plus 0.15 is 2.5%. Greater than 220, well, 220, remember 220 was right here. So that's going to be all of these intervals in here, 13.5, 2.35, and 0.15. So we add those up. 13.5 plus 2.35 plus 0.15 will give us 16%. Okay? So finding these probabilities under a curve really, it's not all that difficult. If you know the average and the standard deviation, you can make your own normal distribution curve. You know, set up your 1, 2, 3 standard deviations above or below. Find the values, and as long as your values hit on a standard deviation, you can compare it. We're going to go further eventually with another thing called a z-score, which will allow us to compare a lot more different types of values, not just between standard deviations. But I think for today, we found some distributions, especially within a standard deviation, or hitting on the standard deviations above and below. We're able to find areas under the curve, find percentages and probabilities. Have these notes ready for tomorrow to be checked. See you then.